Okay, in this video, we're going to look at some properties of probability. Second one will be approaches to probability. Means that what are the methods that we can calculate probability. Third one will be rules of probability, which includes the addition rule, multiplication rule, and another one will be the conditional rule or conditional probability. Okay, then last one we will look at for mutually exclusive events as well as independent events. Okay, now look at some introduction here first. So a probability is a numerical measure on the chance that an event occurs. If an event A is denoted as A, then the probability of event A occurring is denoted by PA. So P here referring to probability. Okay, now look at properties of probability. So each probability, or when we calculate value probability, the value must lie between 0 to 1. So this one please do correction, not 0 and 1, 0 to 1, okay? So for example here, probability of A can be more or greater than 0, but less or equal to 1, okay? So meaning to say that when you calculate probability, your answer cannot be more than 1 and your answer also cannot be negative. Okay, then the sum of the probability is always equal to 1. Okay, for example, if I have, let's say I put here probability of A equal to 0.2. Then probability of B equal to 0.5. Okay, then I ask you to find probability of C. Okay, how to find probability of C? So we know that total probability is always equal to 1. Okay, so total probability of all events here. So 0.2 plus 0.5 is 0.7. So probability of C will be equivalent to 1 minus 0.7, which is 0.3. Okay, so total probability must be equal to 1. So this one also we call it as complement rule. Okay, so complement rule, for example, probability of C equal to 1 minus, so this one I can write it as probability of C equal to 1 minus probability of C prime. Okay, C prime means that does not belong to C, which are A and B. So this is complement rule. Okay, then if A1, A2, A3 and so forth is a finite sequence of mutually exclusive event of S, then probability of A1 union A2 union A3 and so forth will be equal to, so if union means that we apply addition rule. Okay, so probability of A1 plus probability of A2 and so forth. Okay, now let's look at mutually exclusive events. So the two events A and B are mutually exclusive events if both events cannot occur at the same time. Okay, as I explained before, mutually exclusive is where both events cannot occur at the same time. Okay, for example, if Monday 8 to 10 you need to attend STA class, so in the same time means that Monday 8 to 10 you cannot go to other class. So if A and B are mutually exclusive events, then the intersection or probability of A intersect B is equal to 0. Okay, so this one to indicate mutually exclusive events. Okay, look at rules of probability. Previously is properties of probability, so here is rules of probability. Okay, the first one, rule of addition or addition rule. Okay, probability of A or B, or we use union. Okay, so A union, probability of A union B will be equivalent to probability of A plus probability of B minus probability of A intersect B. Okay, if you look at here, we want to find probability A or B. Okay, either A or B. So that's why here we need to minus the intersection. Okay, intersection of A and B means that both. Okay, but now we just want either A or B. So if you look at this Venn diagram, so this one, let's say this one is the intersection. Okay, so we just want either A or B. Okay, so why we need to minus intersection here, area in the middle here? Because value in the middle here will be A and B, means that both events. Okay, so if either one, so you must minus the intersection A. Okay, let's say A is those who prefer nasi ayam. B is those who prefer mee kolok. Okay, so intersection here will be those who prefer both nasi ayam and mee kolok. So if we want to find those who prefer nasi ayam or mee kolok only, so that's why we need to minus those who preferred both, right? Okay, so remember, for addition rule, this one you need to minus the intersection. Okay, now look at special rule of addition here. So if we know that A and B are two mutually exclusive events, then so from this rule of addition, probability of A or B, which is A probability of A union B, will be equivalent to probability of A plus probability of B only. Okay, why? So we know that just now, if that events are mutually exclusive, the intersection will be equal to 0. Okay, so from this first rule, so when you substitute probability of A intersect B equal to 0, so it just left with probability A plus probability of B. So second one is complement rule. Okay, this one I already explained before. So probability of A prime will be equal to 1 minus probability of A. Okay, then multiplication rule. If A and B are two independent events, so just now mutually exclusive. So here independent events. Then probability of A and B, or can be written as probability of A intersect B, just simply equal to probability A multiplied by probability of B. Okay, so intersect multiply union plus. Okay, now let's move to approaches to probability or methods for assigning probabilities. So basically we have three methods: classical method, relative frequency method, or we call it as empirical method, and last one is subjective method. Okay, look at classical probability first, or classical method. So how to calculate probability of an event, or maybe event A, for example here. So probability of A is given by number of outcomes in event A divided by the total number of possible outcomes in that sample space, okay, or in that event. So here also I write it as N. N means that referring to number of sample in event A, and S here referring to sample space, okay, number of sample in sample space. Okay, now let's look at example 15 here. A rental car service facility has 8 foreign cars and 10 domestic cars. So you write the info given. Let's say foreign, I put F, foreign car 8, domestic car D 10. Waiting to be serviced on a particular Saturday morning. There are so few mechanics working on Saturday and only 6 cars can be serviced. Okay, so one day only 6 cars can be serviced. If the 6 cars are chosen at random, so means that we choose 6 only. What is probability? So when question asks you about probability, so your answer later on must be between from 0 to 1. Okay, cannot be more than 1 and cannot be negative. So what is the probability that the 3 of the cars selected are domestic? Okay, 3 of the cars selected are domestic and the other 3 are foreign cars. So 3 plus 3, 6. Okay, so in this question, we can apply concept of combination. Okay, recall under counting methods we have multiplication rule, permutation, and combination. So here we can apply combination concept. So 3 cars selected are domestic and the other 3 are foreign cars. So here will be, so total n here is 8 plus 10 is 18. Okay, so we want 3 domestic, 3 foreign. Okay, so 3 domestic car and 3 foreign car. Okay, so what you can do, probability, let's say I put here as event A, probability of event A, where we want probability of 3 domestic car and 3 foreign car. Okay, so here probability of A equal to, okay, apply combination NCR. So 3 domestic, so domestic we have 10, so 10 C3 and so multiply 3 foreign car NCR AC3. Okay, so this is number of ways that we can choose 3 domestic car and 3 foreign car. Now we want to find probability. So if we want to find probability, so based on this method just now, divide by the total number of possible outcomes. Okay, so the total will be NCR. Total is 18. R is 6. Okay, so 3 plus 3, 6. So when you calculate this one, you get 0.36. Okay, just now, value probability must be from 0 to 1, right? So if you look at your answer here, 0.36, this one is closer to 0, means that less than 50%. Okay, probability also, we can express it in percentage. Okay, so 0.36, we also can use as 36%. Okay, so in this case, to select 3 domestic car and 3 foreign car is only about 36%. Means that there is a low chance to select this combination for 6 cars. Okay, 3 domestic and 3 foreign. If you answer here, for example, 0.8, which is closer to 1, so we can say that there is a high probability for 3 domestic and 3 foreign car to be selected. If we get 0, it means that there is no chance at all. But if we get 1, exactly 1, means that there will be certain the 3 domestic cars and the 3 foreign cars will be chosen. Okay, now let's look at example 16 here. A group of four undergraduate and 5 graduate students are available to fill certain posts at ABC firm. If 4 students are to be randomly selected from this group, find the probability that exactly 2 undergraduates will be among the 4 chosen. Okay, so here you can write the info first. Undergraduate is 4, graduate 5, so total is 9. So you want to select 4 students, R equal to 4. Okay, now we want exactly 2 undergraduate students will be among the 4 chosen. So 2 undergraduate and will be 2 graduates. So probability of, let's say here I put X is 2 undergraduate, exactly 2 undergraduate, and balance will be another 2 graduate. So probability of X, so what is X? Referring to 2 undergraduates and 2 graduates. So we apply concept combination undergraduate 4C2 and multiply by graduate 5C2. Okay, so this is number of ways. So we want to find probability, divide by total all. So total all is 9C4. Okay, so 4 plus 5, 9, 2 plus 2, 4. So this one equal to 0.476. Okay, B. At least one chosen must be a graduate student. Okay, we find the combination of at least one graduate student. Okay, so graduate student we have 5. At least means that 1, 2, 3, 4, 5. So combination of at least one graduate. So will be one graduate and 3 undergraduate. Or 2 graduate and 2 undergraduate. At least one graduate. So graduate we have 5. And or 3 graduate and 1 undergraduate. Or it can be all are graduate and 0 from undergraduate. Okay, so these are combinations for at least one chosen must be graduate student. Okay, now apply the combination. Okay, let's say here I put again x equal to probability of, sorry, not probability, x is at least one graduate student. So probability of x equal to graduate 5. 5C1 multiply undergraduate 4. 4C3. Or plus 5C2 multiply 4C2. Or plus 5C3 multiply by 4C1. Or plus 5C4 multiply 4C0. Okay, so you cannot put 5 graduate, okay, because it is more than 4 here. Okay, this is number of ways. So if you want to find probability, so calculate this one first and then divide by total all. So total all n is 9C4. Okay, so out of 9 we want to select 4 only. So this one we will get 0.992. So if you look at the probability here, 0.992, which is almost or closer to 1, so means that there is a high possibility or high likelihood or high chance, okay, to choose at least one student that are from graduate student. Okay, second method in finding probability, we have relative frequency approach. So the probability of an event happening is determined by observing what fraction of the time the similar events happen in the past. Okay, so for example, probability of event A here is given by number of times an event occurred in the past and then divided by the total number of observations. Okay, look at example 17 here. So we have a sample of 2000 licensed drivers. Reveal the following number of violations. So we have, if number of violations equal to 0, means that all of the drivers obey to the rules, for example. Okay, now look at question. Okay, what is probability that a particular driver in this sample has no violations? So if no violations means that 0 violations. Okay, so let's say X referring to number of violations. So if no violations indicates that value X equal to 0. So how to find the probability? Number of times the event occurred in the past. So the frequency is 1700 divided by total number of observations, which is 2000. So 1700 divided by 2000, we get 0.85. So the probability here is closer to 1, right? Okay, so we can conclude that, so in that particular area, the drivers are all good. Okay, because no violations is almost equal to 1. Okay, question B. 2 or 3 violations. Probability 2 or 3 violations. Okay, or. So now we want to find X equal to 2 or X equal to 3. Okay, so this one, or we apply addition rule. So probability of X equal to 2, so is the frequency 80 if probability divided by total 2000 here, and then plus X equal to 3, frequency is 40, then again probability divided by 2000. So you total up this one, the probability will be 0.06. So means that very low chance, okay, for 2 or 3 violations. 0.06 is 6%, okay, so 6% for drivers who has 2 or 3 violations. Okay, now let's move to example 18 here. A survey of 35 students at the Ing College of Business showed the following majors. Okay, so means that total number of students is 35. So we have 4 majors here: finance, ICT, management, and marketing. Okay, suppose a student is selected at random from this college. What is the probability that his or her major is management? So we want to find probability. Let's say management, I just put NG like this, okay, referring to management. So what is the probability? Number of students in management, 12 divided by total all. So 12 over 35 is 0.343. If you want to leave your answer in fraction also no problem, but I prefer in decimal point. Okay, so we always can check that our answer is between from 0 to 1. Okay, B. What is the probability that the students is from marketing or finance? Okay, or finance. So here we want to find probability of marketing. Let's say marketing, I just put MK, or so you can put union sign. Finance, let's say finance, I put it as F. So here equivalent to probability of marketing, or will be plus finance. So probability of marketing is, so total students under marketing is 5. So probability divided by total, 5 over 35 plus finance 10 divided by 35. So in this case, this is an example of mutually exclusive events. Okay, mutually exclusive means that disjoint, or in this example, one student cannot register or cannot enroll for 2 majors. Okay, if you take finance, then you cannot be student marketing in the same time. Okay, so that is meant by mutually exclusive. So here the answer will be 0.429. Okay, last C. find the probability that his or her major is not ICT. So not ICT. Not ICT referring to finance, management, marketing. Okay. So instead of you add one by one, finance plus management plus marketing, what you can do is you can use complement rule. Okay. Complement rule means that you use 1 minus probability of ICT prime, for example. Okay, let's say here I write it as probability of not ICT. So let's say I put I prime equivalent to 1 minus probability of I. So I is referring to ICT. So not ICT of finance, management, marketing. So why 1? Because total probability must be equal to 1. So what is probability for ICT? 8 divided by 35. So this one your answer will be equivalent to 0.771. Okay. Okay, now last method on how to determine probability. So look at subjective approach. Okay, so what is meant by subjective approach? So subjective probability is the probability assigned to an event based on subjective judgment. Okay, based on subjective judgment, experience, information, and belief. Okay, so based on our experience or belief. Okay, it is usually influenced by the biases, preferences, and experience of the person assigning the probability. So for example here, what is probability that you will earn A plus for ST108? So let's say based on your judgment, on your own, on yourself, okay, you already learned for a few topics. Okay, maybe your probability is 0.9. 0.9 means that closer to 1 means that you believe that 90% you will get A plus for your STA108. Or if I ask you, what is your probability that the MCO will live until end of June? Okay, so based on your judgment or based on your current situation, maybe you can answer 0.7. Okay, why 0.7? Because later on will be Hari Raya, will be Gawai. Okay, so there is a high possibility the new cases of COVID-19 will be rise. So if you believe in that way, so the probability will be higher. But if you put 0 point, for example, what is your probability that the NCO will be lived until end of June? So if you put 0.2, means that most probably will not be continued or not be lived until end of June. So that is meant by subjective approach or based on belief, our judgment. Okay, now let's continue with conditional probability. So conditional probability arises when one probability, for example, probability of A, depends on the other probability of B, which is defined over the same population of events. Okay, so meaning to say that occurrence of one event will be depend on the occurrence of another event. Okay, how to calculate conditional probability or how to write conditional probability? So for example here, the first one, probability of A given probability of B is given by. So this vertical line is to represent given. Okay, so how to read this term? Probability of A given probability of B. So this one equal to probability of A intersect B divided by probability of B. So note here that if for conditional probability, the denominator here must be the condition here. Okay, so now the condition is B. So this one, in order for A to occur, B must be occur first. Okay, so that is meant by conditional probability. Okay, then if we have probability of B given probability of A. So how to write this? Probability of B given A equivalent to probability of A intersect B divided by the condition. Okay, so now the condition is A. So probability of A intersect B divided by probability of A. So here means that in order B to occur, A need to occur first. This one, in order for A to occur, B need to occur first. Okay, so remember the denominator here will be the condition here. So this one condition is B, so this one B. This one condition is A, so here divided by probability of A. Okay, note that probability of A intersect B also equivalent to probability of B intersect A. Okay, so here if you write A intersect B or B intersect A, also the same thing. Okay, now let's look at example 19 here. Suppose that a balanced dice is tossed once. Find the probability of tossing a 1 given that an odd number was obtained. Given that, so this is the condition. Okay, first we list the sample space or all possible outcomes based on this experiment. So here we can write S, which is sample space. So either we get number 1 or number 2 or number 3 or number 4 or number 5 or number 6. Okay, so that is sample space for this experiment. Okay, now we define the event. Okay, let's say I put let A be the event tossing 1. Okay, means that when you toss that dice, you will get number 1. And let B be the event of getting odd numbers. Okay, getting odd numbers. Okay, now we list all the sample space under each event. So event A, so what is the sample space? So if based on this experiment, so tossing a 1, so means that the sample space will be number 1 only. Okay. Okay, for event B, the sample space will be getting odd numbers. So odd numbers from this experiment are 1, 3, 5, 1, 3 and 5 only. Okay. Okay, now we want to find probability. Okay, so we need to know number of sample space for each event. So event A here, number of sample is 1. Okay, because we only have one number for number 1. And for event B, we have 3 numbers, so n equal to 3. Okay, now how to convert this sentence into mathematical sentence like this? So we want to find probability of tossing a 1. So tossing a 1 referring to event A. So probability of A given that odd numbers was obtained. So odd numbers referring to event B. Okay, so that's how we convert the sentence into mathematical sentence like this. Okay, we know that probability of A given B is equal to probability of A intersect B divided by the condition. Okay, so now condition is B, so divided by probability of B. Okay, now we need to find what is A intersect B and what is probability for B. Okay, if you look at from this sample space, okay, A intersect B is 1. So we can list here A intersect B. The sample space is, or the element is only number 1. Okay, then we need to find the probability. Okay, probability of A intersect B and probability of B. So how to find probability of A intersect B? So recall how to calculate probability. So probability of A intersect B. Okay, number of elements in A intersect B is only 1, right? So 1 out of, so total sample space is 6. So 1 over 6. Okay, now we already have value probability of A intersect B. Okay, find probability of B. So what is probability of B? So we know that number of sample in event B is 3. So probability divided by total sample space, which is 6. So 3 over 6. So this one also can be written as 1 over 2. If you want to write your answer in decimal point also, no problem, okay? But make sure when we calculate probability, our answer must be from 0 until 1. Okay, how to find probability of A intersect B, A given B? Okay, substitute the values. So probability of A given, A intersect B just now is 1 over 6. So 1 over 6 divided by the condition, which is probability of B. So probability of B is 1 over 2. So this one we will get 0.333. Okay. So you give answer in 2 decimal point also no problem. 3 also no problem. 4 also no problem. Okay. So again, make sure when you calculate probability, answer must be from 0 to 1. Cannot be more than 1 and cannot be negative. So 0.333 here indicates that the chance for us to get number 1, given that a number occurs first, is low. Okay, why low? Because the probability is only around 33.3%. But however, if you get your answer, for example, 0.89, okay, or 0.89, closer to 1, right, or almost 100%, not almost 100%, but closer to 1. So if you get 0.89, for example, okay, it means that there is higher probability or high probability or high chance for us to get number 1, given that the odd number occur first. So that is an example of conditional probability. Okay, now let's look at this example. Okay, suppose that of all students buying a certain brand of computer, 60% include a word processing. So again, probability also can be expressed in percentage. So if 60% means that 0.6. 40% include spreadsheet program and 30% include both types. Okay, given that the selected student included a spreadsheet program in his purchase, what is the probability that a word processing program was also included? So here we want to find probability of, so probability that word processing included. Then which one is the condition? So normally keyword for conditional probability is given. Okay, either given or if. So they want to indicate conditional probability. Okay, we extract the information given first. So 60% for word processing. So let's say I put probability of word. So W referring to word equal to 0.6. And 40% includes spreadsheet. So probability of S 0.4. And 30% includes both types. So both means that word and spreadsheet. So this one means that the intersection. Okay. So probability of word intersect S equivalent to 0.3. Okay, now how to write this sentence into mathematical sentence. So look at here, we want to find probability that a word, so probability that a word given, so given the condition, the selected student included a spreadsheet program. So W given So probability of W given S is equal to probability of W intersect S divided by the condition. So now the condition is S. So divided by probability of S. Okay, then substitute the value. Probability of W intersect S is given by 0.3 divided by probability of S 0.4. So this one, the probability is 0.75. So here, let's say when you buy a computer, the possibility or the likelihood, or we also can say that the chance, okay, for a student to have word processing program, given that it has spreadsheet program, is 75%. So 75% we can say quite high chance, okay, because exceeded 50%, okay. So for me, if exceeded 50%, I will consider there will be a high chance for us to get that certain probability, okay. So if 0.75, okay lah. Okay, now let's look at independent events. Okay, the two events A and B are said to be independent if the occurrence of one does not affect the probability of the occurrence of the other. So here example of experiment is we toss a coin, okay? So for example, the occurrence of second outcome is not depend on the occurrence from first outcome, okay? For example, you have a coin and you toss it twice. Okay, first toss you get tail. So second toss you get head, for example. Okay, so on second toss you get head is not depend whether you get tail first. Okay, so that is meant by independent event. So A and B are independent events if the probability of A intersect B equivalent to probability of A multiplied by probability of B. So dot here means that multiply, okay? Okay, let's say we take example from example 19 previously, experiment tossing a dice. So here recall the examples. Okay, so if we toss a dice once, we will get either number 1, 2, 3, or 4, or 5, or 6. Okay, now A is even tossing a 1 and B is even getting odd numbers. Okay, how to determine whether these two events A and B is independent or not? Okay, so it is said that probability of A intersect B equivalent to probability of A multiplied by probability of B. So here we have probability of A intersect B is 1 over 6. Probability of A is 1 over 6. Okay, so A we have one element only, so probability is 1 over 6. Total sample space here is 6. And probability of B is 3 over 6 or equivalent to half. So how to determine whether A and B is independent or not? So A and B are independent if probability of A intersect B equivalent to probability of A multiplied by probability of B. Okay, now we know that probability of A intersect A prime is 1 over 6. So 1 over 6 should be equal to probability of A multiplied by probability of B. So probability of A just now is 1 over 6 multiplied by probability of B is half. So if we calculate here, is it probability of A intersect B equivalent to probability of A multiplied by probability of B? So 1 over 6 1 over 6 multiplied by half will be equivalent to 0.083. So 1 over 6 is equal to 0.167, right? So this one, if you want to round off to, sorry, if you want to write in decimal point also, no problem. So we know that 0.167 not equal to 0.083. Okay, so if not equal, so we can conclude that A and B is independent or dependent. So we can conclude that A and B are not independent. Not independent also can be said as dependent. Okay, dependent events. Okay, so that's how we determine whether the two events are independent or not. Okay, let's say probability of A intersect B is 0.167, and then the probability of A multiplied by probability of B also you get 0.167. Then we conclude the two events are independent. Okay, now look at the multiplicative law of probability. So the probability of the intersections between the two events, which are event A and B, is given by probability of A intersect B is given by probability of A multiplied by probability of B given A. Or this one also can be written as probability of B multiplied by probability of A given B. So this one the condition is A, this one the condition is B. So this formula is actually comes from the conditional probability formula previously. Okay. So how to get probability of A intersect B? So means that if you want to find this value, if you have conditional probability like this from this conditional probability, so you just derive this formula. Okay. So probability of A intersect B divided by probability of B. So if you want to find probability of A intersect B here, bring the denominator to left hand side. So here divide to left hand side becomes multiply. Then you get this formula. Okay. So A probability of A intersect B. So you want to find this one will be given by probability of A given B multiplied by probability of B. Okay. So similarly, if you have probability of B given probability of A, so you want to find the intersection here, probability of intersection events here. So bring the denominator to left hand side. So here will be probability of A intersect B equal to probability of B given A multiplied by probability of A. So after this, we look at example on how to apply this law. Okay, now look at example 21. Suppose that probability of A given B equal to 0.3 and probability of B equal to 0.4. Okay, calculate the probability of A intersect B. So based on the info given here, we have conditional probability. So we can use conditional probability formula in order to find probability of A intersect B. So probability of A given B equal to probability of A intersect B divided by condition. So now the condition is event B. So divided by probability of B. Okay, substitute the value. A given B is 0.3. So we want to find probability of A intersect B divided by probability of B, which is 0.4. So probability of A intersect B equal to 0.3 equal to 0.3 multiplied by 0.4. So probability of A intersect B equal to 0.12. Okay, number 2 here. Find probability of A prime intersect B. Okay, if you have this type of question, A prime here, so it is advisable for you to use Venn diagram. Okay, so based on Venn diagram, we can see where is the region for probability of A prime intersect B. Okay, now let's draw the Venn diagram. Okay, now we want to find area. Where is area A prime intersect B? Okay, so let's say here I draw a circle for event A first, and then this one for event B. So area in the center here or in the middle here will be intersection of A and B. So this is A, this is B. So this one is a whole set. Okay, now where is area A prime intersect B? Intersect area that are overlap. Okay, so look at A prime. A prime means that does not belongs to A. So where is the area A prime? So this is A prime. This one also A prime. Okay, not belongs to A. But now we want A prime intersect B. So which area A prime intersect B? Okay, so this is A. So yellow area here will be A prime. Area that is not belongs to A. Okay, B, where is B? So this is B. Okay, so where is the overlap area of A prime and B? This part. Okay, so that is area A prime intersect B. So purple area here is area that we want to find. Okay, we want to find the probability. So this is area probability of A intersect B. So this one is not probability yet. Okay, but area A prime intersect B. Okay, so how to find probability of this purple area? Okay, by looking at this Venn diagram, we can find this probability by, so look at here, this is B, so probability of B. So how to get purple area here? We need to minus this area. Okay, so this is area what? A intersect B. So in order to find A prime intersect B, so it is given by probability of B minus probability of A intersect B. Okay, now look at how to write the answer. So probability of A prime intersect B is given by, so this area, probability of B minus probability of this area in the middle, which is probability of A intersect B. So probability of B, we know that probability of B just now is 0.4 minus probability of A intersect B is 0.12. So this one equal to 0.4 minus 0.12 is 0.28. Okay. So again, if you have question like this, A prime or B prime, means that events that is not belong to a certain event, you draw Venn diagram in order to help you to answer the question. Okay, now let's look at question B here. Suppose that probability of A given B equal to 0.2, probability of A given B prime equal to 0.4, and probability of B equal to 0.8. Okay, calculate probability of A. Okay, again, how to start answer this question? Okay, use information given. Okay, so now you have conditional probability here. So you always can start from the conditional probability. So let's start from probability of A given B. So probability of A given B equal to probability of A intersect B divided by the condition, which is probability of B. Okay, then you substitute values that you had. Okay, so A given B, we know that it is equal to 0.2. Okay, probability of A intersect B, so we don't have probability of A intersect B, so you just write back probability of A intersect B divided by probability of B. So probability of B is 0.8. So from here, we can get probability of A intersect B. So A intersect B equivalent to 0.2 multiplied by 0.8. So this one will be 0.16. Okay, now use second info, probability of A given B prime. Probability of A given B prime. So this one is equal to probability of A intersect B prime divided by the condition which is B prime. So divided by probability of B prime. Okay, substitute the value that we had. So probability of A given B prime is 0.4. Then you write back probability of A intersect B prime. Okay, since we don't have this value yet. Okay, so what is probability of B prime? So we know that probability of B is 0.8. So here we can calculate probability of B prime. So you can apply the complement rule. So probability of B prime 1 minus 0.8. So probability of B prime is 0.2. So here divided by 0.2. So now we can find probability of A intersect B prime equivalent to 0.4 multiplied by 0.2. So this one, probability of A intersect B prime equivalent to 0.08. Okay, now we want to find probability of A. So here we have probability of A intersect B and we have probability of A intersect B prime. So again, as I said before, if you have something like this, B prime, A prime, use Venn diagram in order to help you to answer the question. Okay, now let's draw the Venn diagram and find where is area A intersect B prime. Okay, now we want to find area A intersect B prime. Okay, draw circle for A and then for B. So this is A, let's say I put A here. And this is B. Okay, find which is area A intersect B prime. So this is area A. This is area B. So what is B prime? Area that is not belongs to B. So where is the area? Area B prime. So this is B prime. And this is also B prime. Okay. But now we want to find intersection between A and B prime. Okay. A that overlap with B prime. So if you look at yellow area here, where is area overlap for these two? Overlap area for these two. This is A and then this is B prime. So this is the area. So let's say I put blue color here. Okay, so that is area A intersect B prime. Okay, so this is the area. Okay, how to find this area? Blue area here. Okay, if you look at this Venn diagram, so we can find blue area by subtracting area A and the intersection part, right? Okay, so area A minus intersection part here, then we will get blue area, which is area A intersect B prime. Okay, now look at how to find probability of A. So use Venn diagram before. So we know that probability of A intersect B prime is given by, so this area, blue area just now, is given by probability of A minus intersection of A and B. So this one equal to 0.08. Okay, so A intersect B prime here is equivalent to probability of A minus probability of A intersect B. So this one equal to 0.08. So now we can find value probability of A. So probability of A equal to, so just now we already have value A intersect B, right? So which is 0.16. So this one equal to 0.08. So probability of A equivalent to 0.08 plus 0.16. So finally, we get value probability of A equal to 0.24. Okay, for example 22, 23, 24 until 25. So I want you to try on your own. Later on, I will give you the answer, okay? After this, we will continue with Bayes' theorem and tree diagram.